To find the answer for these questions, you find in my what? In my posted YouTube video last class and also the Excel spreadsheet. What I'm going to cover today is called the PERT, 3-estimate approach. First one, 3-estimate. What are the 3 estimates? First one, most likely estimate, denoted by M, M as mother. Estimate of the most likely value of the duration. Optimistic estimate, abbreviated as O, estimated the duration under the most favorable conditions. Pessimistic estimate, P, estimate of the duration under most what? Unfavorable conditions. Okay? We have M, optimistic O, pessimistic P. Most likely estimate in the distribution. What is most likely? The one with highest what? Peak in the distribution. The location. That its probability is what? Is largest. This is the location, see a peak, okay? The highest peak. Some people also call this is what? Mode. Okay? Mode is actually this location. Okay, you see the highest peak. Okay? Now, let's flip to the next page. In project management, we use beta distribution to estimate the distribution of activity times, okay? An approximate formula for mean duration of an activity, is optimistic estimate plus 4 times most likely plus pessimistic estimate divided by 6. This is for average, mean. An approximate formula for sigma. Okay, this is actually what? This is actually, I should put a square here, okay? Sigma square. Sigma is standard deviation, okay? And sigma square equal to standard deviation square equal to variance of an activities, okay? If this is modeled by beta distribution, we have a very good estimation formula, okay? Mean is what? Optimistic plus 4 times most likely plus pessimistic divided by 6. And approximation formula for variance, the duration, variance duration of an activities is pessimistic subtract optimistic divided by 6 and the whole thing squared, okay? And 3 simplifying approximations. So we give you 3 what? Assumptions, okay? Something you should think about from a statistic point of view. Probability distribution of a projection duration. 1. What is the mean denoted by mu p of the distribution? 2. What is the variance of the distribution? 3. What is the form of this distribution? Okay, we're going to give you what? step-by-step explanation. Let's first begin with simplifying application 1. Assume that the mean critical path will turn out to be what? The largest path through the project network. This is only a rough approximation, since assumption occasionally does not what hold. In the usual case, where some of the activity duration do not equal to their mean. Okay? Fortunately, when the assumption does not hold, the true largest path commonly is not much what? Larger than the mean critical path. Okay? Say, let's use this one as what? As an example. Okay? Say this is my start. This is a AON project network. To A, this is to B. This is example 1 we explained last time. Okay? And C is right after what? A and B. Same for D. Okay, same for D. And E is right after D. This is a finished node. Okay? We know this is what? In our example, we know B to D to E is a critical path. It is a critical path because the expected value of xb to xd, let me use what? Let me use addition, okay? What's xb? xb is a random variable. The random duration of what? Activity B. And this is the duration of, in the real life application, is a random variable. And exp is its estimated value. This is the mean duration. Usually, the duration of activity B will not exactly equal to what? Its mean. Okay? This is average. This is what? Random variable. So, if I tell you this is the critical path, B to D to E, it's a critical path in what? In mean. Okay? EXB, and this is to what? To D to E. This path is greater than what? Greater than all others. For example, A to C. Okay? Usually, when we say this is longest path, it's from what? Expected value polynomial B. The expected duration of xb plus xd plus xe is longer than that of xa and what? xc. And any other path, this is the longest one compared to the other path. This is the longest one. But expected one is longest one doesn't mean in the real life it's still the longest one. Okay? As you know, that what I mean is the new duration from xb to xd to xe, the time, usually will not exactly equal to its expected value. Okay? But if this is a situation, okay, say a lot of bad things happen to A. So it's not like an average performance or duration of A. This lasts very long. Expected value may be just what, 2 weeks. But if the project manager got sick, and you need to find somebody to replace the project manager, and some machine is too old, running too slow, so you need to buy a new one, right? And then there are some accident. Make a duration. Usually, its expected value is 2 weeks. But when bad thing happen, it can last for what? 2 months. In that case, it may be even bigger than XP or XT all combined. Okay? So that's what I mean. We say from B to D to E is what? It's shortest in its mean. But the real life, some other thing may happen. Okay? So the expected one, the longest one, not necessary in the real life, is still the longest one. Okay? So that's why we come with what? Simplifying approximation. Let me read that again. Assume the mean critical path will turn out to be what? The longest path through a project network. This is only a rough estimation, since assumption occasionally does not hold. In usual case, where some of the activity duration do not equal to zero mean. Fortunately, when the assumption does not hold, the true longest path commonly is not much longer, okay, than the mean what? Critical path. That's the first assumption we made, okay? And second one, simplifying assumption 2. Assumption that the duration of the activity on the mean critical path are statistically independent. Okay, what does that mean? What happened to A will not affect to what? What happened to C? But this is usually a very strong assumption. Say John always late to the job, okay? And he always what? 2 hours early leave the daily duty, okay? So the other people work 8 hours, and John only work what? John only work 4 hours. And because John, the whole project delayed. And John also involved with C. What can you say about C? Well, C will also be delayed, right? One student asked me before, he said, Scott, that won't happen. I say, why? He said, in the real life application, if John is a troublemaker in project A, in activity A, and if company know that, when they come to what? Activity C. If you find this is late and John is still in activity C, then they will remove C. I say, no, John will not be removed from what? Activity C. Because his dad is the owner of the company. Okay? So that can happen. So usually, if you don't see in that extreme case, you can think about in activity C and A both share what? The same old machine. And because an old machine, it breaks down many times. So A is delayed, that means C will also be delayed because they use the same machine or same equipment. Okay? So simplifying approximation 2 is actually what? A very strong statement. Okay? The very strong assumption. We assume the duration of activity on mean critical path are statistical independent. That means what happened in A will not affect what? What happened in A will not affect what happened to C. So this is a very strong statement, okay? Thus, the 3-estimate of the duration of activity would never change after learning what? The duration of some of other activities. This assumption should if the activity are performed truly independently of each other. However, the assumption becomes only a rough approximation if the circumstance that causes duration of one activity to deviate from the mean also tend to cause similar deviation from what? Some other activities. Okay? This is simplifying assumption what? Number 2. Okay, let's look at the last one, simplifying approximation 3. Assume that the form of the probability distribution of project duration is normally distributed To justify this assumption as being a reasonable approximation, we need to have what? The number of activity on the mean critical path is what? Not too small. So we can apply the central limit zero. Okay? The central limit zero means what? When the duration of each activity on the critical path, mean critical path, and there are many activity on what? On the mean critical path. Then the approximation, you sum them up, they will be look roughly what? Roughly follow a normal distribution. Okay? So let me explain clearly about this assumption. Okay? Okay? Now, what assumption 3 says is the project completion time, xb plus xd plus xe. Why you call this is project completion time? Because expected duration of what? xb plus xd plus xe is the longest one. Longer than any other path in the project network. Okay? So the project completion time is determined by what? The duration of xb plus xd plus xe. Assumption 3 tell us, we assume this is normal. But usually you want to see what? More activity on the critical path. In the real life application, 3 is definitely what? Too small. You probably want to see 10, okay? To get a better normal approximation, okay? But we just use 3, easy for our explanation, okay? So assumption 3 says what? The activity duration, you add up the 1, B, and you add up the activity D, you add up the duration of E. You can use this one to say this is project completion time. And project completion time will follow normal. If we have a lot of what? Activity on the critical path. Okay? Now, it's normally distributed. Although each one, XB follow what? Beta. XD also follow beta. And XE also follow beta. Individual duration in the project follow beta distribution. But when you sum them up, okay, by central limit zero, they will follow approximately normal with a mean duration time and the variance of the duration time. Okay? And if you still remember, in 2 weeks ago, I posted the mean expected variance. So we're going to use the video. If you don't know what I'm talking about, go back to read what? The expected and variance of random variable. I think I posted it 2 or 3 weeks ago. Okay? You should read that video. So by the property of expected value, okay? By the property of expected value, I'm going to list 3 properties, okay? I'm going to write here. Okay, let's recall the video. I posted about 3 weeks ago. 3 property of expected value of a random variable. Okay? Property 1. Expected value of a constant is a constant itself. Property 2. Expected value of constant times random variable x going to be what? C times expected value of the random variable. And 3, expected value of x plus y is ex plus ey. That is the 3 property you should know about what? Expected value. Okay? Or mean of a random variable. Now, next one I'm going to talk about 3 properties you should know about the variance of a random variable. Property 1. Variance of a constant is 0. Constant has no spread. Okay? Variance is used to measure the spread. Okay? the dispersion of a distribution. But if this is just a constant has no spread. Variance is 0. Second one, variance of Cx is C squared times variance of X. Okay? You pull the C out, unlike what? This is what? Pull it out is CEX. You pull this out, this become C squared variance X. And 3, variance of X plus Y, going to be variance of X plus variance of Y. Okay? And this one requires assumption, which is X, Y need to be independent. But independent is not needed here. It's needed here. Okay? So let's come back to see what we're going to get from the 3 assumptions we just mentioned. Okay? If all activity in the project network, or you say all the activity on the critical path, they are independent. By property 3, you can write this one as variance of XP plus variance of XT plus variance of XE. Okay? Now, this one, by 3 property on expected value, can be written as EXP plus EXT plus what? EXE. Okay? So let's rephrase what? The 3 assumptions we just stated. Why we set the project completion time as XP plus XT plus XE? Because the expected duration of XP plus XT plus XE is the longest. Okay, that's our first assumption. Even this is not true. Hopefully the other one will not too longer than this one. Okay, that's our first assumption. Second assumption, we assume all the activity on the critical path, they are statistically independent. If they are, we can write variance XP plus XT plus XE as what? Variance XP plus variance XT plus what? Variance XE. Okay? And then third assumption, this one is roughly follow what? The normal distribution. Okay? So just talk about this can be very dry. So let's look at what? Example 3 for a concrete example. Okay?